We are now moving into our energy, power, and climate change questions, and so we're going to be using these formulas over here. Now, it's really important that you take time to learn what each of these symbols are. I'm not going to go through this in detail now, just use one or two of them, but it's you've got to really know what each of these symbols are and what they all stand for. So in 27, a wave generator produces a power per unit length of 4 kilowatts per meter for wave of amplitude A and speed V. The efficiency of the generator is constant. The power per unit length obtained for waves of amplitude 2A and 2V would be. Now we've got to use one of these formulas. Now which formula? Well, it's actually this one. This is the power per unit length. So that was a bit of a clue for you. But power per unit length for a wave. So we've got this, it's equal to dependent on a square for our A, which is actually the amplitude of the wave, and V. All of these other two are constants. This is your gravitational constant, you're due to acceleration, and this over here is the density of the water. So it's going to, so because it's doubled, so this is a square term, so it's going to be lead to 4 times, and then it's doubled, so it's going to be times 2. So there's actually going to be an 8 times increase. So it's 4, so to be 4 times 8, the answer would be C. Going on to 28, we have the diagram shows the variation with wavelength of the power per unit wavelength radiated from an area of 1 meter squared of 2 different bodies. Which of the following is a correct comparison of the temperature and the emissivity of the two bodies? Okay, now the temperature of the body actually depends on this wavelength here, where you get your maximum intensity. So we can see that these two are different. So definitely the temperature is going to be different because we've got our lambda max is different for each one. So the temperature is going to be different. So we're looking at C and D. And the emissivity is the amount of energy that's actually being emitted per unit area, per time interval. So we can see here that this is totally different. These two are totally different, your emissivity, so they would also be different. So it would actually be D would be the correct one there. And then going over the page here, we've got last two questions. The first one is pretty straightforward. Which of the following is the most likely explanation for a rise in global sea levels? It's actually going to be A. Although it's a very small amount, this thermal expansion of water with temperature, because of the huge volumes, the huge volume of water, this is actually the one that's actually going to lead to the greatest change in the sea level. Okay, and then 30, the diagram shows an energy balance climate model for a planet. So you've got your incoming intensity that's coming from your sun, and then you've got your reflected from the atmosphere and your reflected from the planet. And then it says the intensity of the reflected and radiated radiation are given in terms of the incident intensity I. Which of the following is the albedo of the planet? Now, albedo is given in this formula over here. So it's a total scattered power, and that would be these two over here. These are the reflected ones. So it would be 0.25, 0.15, so it becomes 0.4 of the total amount. This radiated by this is after it's been absorbed, and then it's radiated as with a longer wavelength. Usually infrared light gets radiated, so this is as a form of heat. So that's with albedo we're looking purely at reflected light. For instance, when you have snow on the ground, you're getting a very high albedo because you're getting a lot of reflection taking place. So this would be C, would be a correct answer. Okay, so that finishes the answers for this paper.